Look up at the moon tonight. It seems perfectly still, silent, unchanging. But there is something happening above our heads that you cannot see. The moon is slowly moving away from Earth. Every single year, it gets about 1.5 inches farther away. That is roughly the width of a human fingernail. It sounds insignificant, but this tiny movement is happening continuously, year after year, century after century, for billions of years. And the strange part is, Earth itself is helping the moon escape. But why? And where is the moon going? Could it one day leave Earth completely? And what would happen to our planet if it did? Tonight on Skywatch World, we're going to uncover the hidden cosmic battle between Earth and its moon. To understand why the moon is moving away, we have to travel back billions of years. The moon was not always where we see it today. Scientists believe the moon formed roughly 4.5 billion years ago, after a massive collision involving the young Earth and another planetary body. NASA notes that evidence from the moon's present orbit and its recession from Earth helps scientists reconstruct this ancient history. But after the moon formed, it was much closer to Earth. Imagine looking into the ancient sky. The moon would have appeared enormous, much larger than the moon we see today. And Earth itself was spinning dramatically faster. A day on the young Earth may have been far shorter than today's 24 hours. Over immense stretches of time, something began changing. Earth started slowing down, and the moon started moving outward. The two were locked in a gravitational dance, and that dance is still happening today. The first thing we need to understand is gravity. The moon pulls on Earth, and Earth pulls on the moon. But the moon's gravity also pulls on Earth's oceans. That creates tides. The oceans bulge slightly toward the moon, and another tidal bulge forms on the opposite side of Earth. You can actually see the result every day: high tide, low tide, high tide, low tide. But there is a hidden detail. Earth is rotating, and it rotates faster than the moon travels around Earth. So the tidal bulge doesn't point perfectly toward the moon. Instead, Earth's rotation carries the bulge slightly ahead of the moon. And this tiny difference changes everything. Because that bulge is made of enormous amounts of water and moving material, and it has gravity too. So the bulge pulls on the moon, but not simply inward. It gives the moon a tiny gravitational push forward along its orbit. And that is the key to understanding why the moon is moving away. Think about a spinning figure skater. When the skater changes the distribution of mass, their rotation changes. Earth's system works differently, but the principle of angular momentum is important here. The Earth-Moon system is constantly exchanging angular momentum. Earth's rotation is gradually slowing. At the same time, the Moon gains orbital energy and moves into a slightly higher orbit. In simple terms, Earth is giving some of its rotational energy to the Moon. The result? The moon moves farther away. NASA estimates the current recession at approximately 3.8 centimeters per year, or about 1.5 inches. That means while you are watching this video, the moon is already moving away. Not dramatically, not visibly, but measurably, and scientists can detect it with extraordinary precision. But how can scientists possibly measure a movement of only a few centimeters per year across a distance of nearly 384,000 kilometers? The answer is laser light. During the Apollo missions, astronauts placed special mirrors called retroreflectors on the lunar surface. Scientists can fire laser pulses from Earth toward the moon. A tiny fraction of that light reflects back. By measuring how long the journey takes, scientists can calculate the distance between Earth and the moon with extraordinary precision. And these measurements reveal something remarkable. The moon really is moving away, about 3.8 centimeters every year. Imagine measuring the distance to another world with enough precision to detect something smaller than your hand. This is one of the clearest examples of how modern science can reveal movements that human eyes could never see. The moon's escape comes with a price. Earth is losing rotational energy, and that means Earth's rotation is slowing, very slightly. Our days are gradually getting longer. Not enough for you to notice tomorrow or next year, But over geological time, the difference becomes enormous. Billions of years ago, Earth rotated much faster. The young planet had shorter days. As tidal friction transferred energy away from Earth's rotation, the planet gradually slowed. At the same time, the moon moved outward. So there is a remarkable connection: longer Earth days and a more distant moon. They are two consequences of the same cosmic interaction. The moon isn't simply wandering away. Earth is slowly pushing it outward through tides. So does this mean the moon will eventually escape Earth? At first glance, it might seem inevitable. If the moon moves away every year, just wait long enough and eventually it should disappear into space. But the universe doesn't work that simply. The moon's recession is not a constant speed journey. As the Earth-Moon system evolves, the rate changes. Eventually, tidal interactions would lead toward a state where Earth and Moon become mutually tidal locked. The same basic physics that has already locked the Moon's rotation to its orbit would continue shaping the system. But there is another enormous problem: the Sun. Long before the Earth-Moon system could reach many of these extreme far-future states, the Sun itself will undergo dramatic changes as it ages. The distant future of Earth will be determined by the evolution of the entire solar system, not just the Moon. But there is one fascinating consequence we can understand much more easily. The Moon appears almost exactly the right size in our sky to completely cover the Sun during a total solar eclipse. That is a remarkable cosmic coincidence. But as the Moon moves farther away, it will appear slightly smaller from Earth. Eventually, the Moon will no longer appear large enough to completely cover the Sun. Total solar eclipses as we know them would eventually disappear. Instead, future observers could see annular eclipses. The Moon would pass across the Sun, but a bright ring of sunlight would remain visible around it. So, the spectacular total solar eclipses that humans experience today are part of a temporary era in Earth's astronomical history, a cosmic window. And that window is slowly changing. And what about Earth's oceans? The Moon is the main driver of Earth's ocean tides, although the Sun also contributes significantly. As the Moon gets farther away, its tidal influence becomes weaker. That doesn't mean Earth's oceans would suddenly become motionless. Waves would still exist, storms would still exist, ocean currents would still exist, and the Sun would still generate tides. But the Moon's contribution would gradually diminish. The relationship between Earth and Moon would become different. And once again, a tiny change happening today could become significant across astronomical timescales. That is the strange thing about space. A movement that is completely invisible during a human lifetime can transform worlds when given millions or billions of years. The Moon moving away from Earth teaches us something much bigger. Earth is not a static planet. The Moon is not a static world. And the solar system is not frozen in place. Everything is moving. Everything is interacting. Gravity is constantly transferring energy and angular momentum. The oceans rise and fall. Earth spins. The Moon orbits. The orbit slowly expands. And the length of Earth's day slowly changes. From our perspective, the night sky looks permanent, but it isn't. The universe is constantly changing. We simply live for such a short amount of time that most cosmic changes appear frozen. So tonight, when you look at the Moon, remember this: it isn't exactly where it was yesterday. It isn't exactly where it was 1,000 years ago. And it won't be exactly where it is today, 1,000,000 years from now. The Moon is slowly moving away, only centimeters each year. But those centimeters are evidence of a gigantic cosmic process, one that has been shaping Earth and Moon for billions of years. The tides are not just waves on a beach. They are part of a gravitational exchange between two worlds. And every night, as the Moon crosses the sky, Earth is quietly giving a little of its rotational energy to its ancient companion. The Moon is moving away, slowly, silently, and relentlessly. This is Skywatch World, where we look beyond the sky to understand the universe around us. Subscribe, because the universe is still moving, and we're just getting started.